This is part 2 of the video where I'm creating an arcade game with the help of ChatGPT and the Walkwi Arduino simulator. Just to recap, we've got to the point where we have hooked up the buttons, we're reading the values from the buttons, we're drawing a spaceship on the screen. We really need to move that spaceship around the screen with accordance to the buttons. So we're going to go back to chat and ask it how it would hook this up. I think what we'll do is we'll copy this loop code here and we'll give that to ChatGPT and see if it can help us out with moving the spaceship. Can you look at following code and help me move my sprite around the screen when the buttons are pressed? And then I'll paste in that code. Okay, so it looks like it's doing a reasonable job here, analysing the code I already gave it. And what's great here is it's reusing the code that I've given it, so it makes it much easier to copy and paste it in. So it's defined a variable xy and it's moving that variable and it's passing those variables to the draw spaceship routine. Let's see what that does. So was that the entire loop? Yes, it was. So we'll replace that with this. See what happens. Okay, so let's press the down button. Okay, so the left button works. Okay, this might be my fault. Did I get these messed up? So button forward, really, yeah, okay, so in the coordinates that I want, we want to actually add that value, not take it away. And button up, no, that's not true. We do want to go up. No, where are we? Button forward, we want to increase X. And button up, we want to take it up in the Y direction. Button left, we want to take that away. And then button down, we want to change the Y. Let's see how that works. So button down, yes. Button up, yes. Forward and back. Beautiful. I just made a quick change there to change the X and Y variables to spaceship X and spaceship Y, to save a bit of confusion later on. Next, I think we need to see if we can get the spaceship to fire a missile. What I've decided to do is pass chat the loop here, which isn't too large, and I've written a whole bunch of logic in comments here, which hopefully I can get it to fill out for me. And what I've said is, when the fire button is pressed, the missile should appear at the nose of the spaceship and travel in the positive X direction until it reaches the screen edge, which is at X equals 31. The missile is simply a single pixel. The missile cannot be fired again until it has disappeared, and the missile should move one step every 100 milliseconds, which is defined in a variable. That's a lot of information. I hope that it is able to take that and produce something for me. Can you examine this code and implement the logic specified in the comments. I'm not going to correct my spelling. It's smart enough to figure that out. And I'm too dyslexic to be bothered. Well, it seems to be producing quite a lot of code. But is it good code? So it's added a new variable to keep track of its position. A -1 indicates there are no active missile when the fire button is pressed. Checks if there is missile active. If not, it sets its starting position to the spaceship X+1. Yeah, we'll have to set the Y, I guess. All right, let's have a bit more of a look at it. So, it fires the missile. Where does it draw the missile? Erase pixel, missile X, spaceship Y. So it's taking the spaceship Y variable. Okay, let's have a look at this. Let's see if we can get this to... I'll copy this code. Why not? Why not just bung the whole thing in? What happened there? Did it not compile? Okay. Oh. Okay, so it's that's my variable. It's reused it. Erase pixel is not declared in this scope. Okay. So we need to... So we've got set pixel. So we'll just use set pixel, and erase is setting the pixel to off, and set pixel true. Right, see if that compiles. Yeah, it does. All right, so let's press the fire button. Whoa, and there it goes. And of course, we actually want the... So if I keep pressing it, nothing happens until it goes off the end of the screen. Great. So all we need is for it to come out of the nose. And so we just need to bring it down in the Y direction for 3 pixels. And have it in, and the starting position will be here. Which means that its logic of using the starting position as -1 isn't great. We'll see if we can work with that. So let's take a look. Well, I think we can work with that. So when the button is pressed, it sets the missile X position. So really, it's the spaceship's nose. So it will be probably at pixel 4. And we need to set the... We need to have a missile Y. It's setting at the spaceship Y, which is great. But really we want it at... No, we need to have another variable. So int missile Y. It's -1. We might as well use the same type of thing. And we will set missile Y to equal spaceship Y plus 3 or 2. Well, we'll soon find out. And then we will come down here and we will use the missile Y. Variable. Looks reasonable. Let's see what happens. Press fire. Okay, it's just one off in the Y direction. No problemo. So we'll go back up here and it was spaceship Y plus 2. Being one off is a programmer's curse. Basically, it happens to everybody. So if we move the spaceship down to a different position and then press it, it should shoot the missile from there. And if we move it up, shoot it from there. And if we keep firing, nothing will happen while it's in motion. Yep, that's another win for ChatGPT. I need to address an issue here. And it's got to do with the pressing of the buttons and how fast the missile is moving. Because this is simulated, everything appears to be at quite a reasonable speed. I hold down the button, it moves once. I press this, it moves slowly across the screen. In real life, it would actually move blindingly fast. And pressing the button, if I held down the button, it would read it very, very quickly, and that spaceship would move instantly off the screen and you wouldn't be able to see it. So we need to do some things with timing. So the button side of it, it's called debouncing. And basically what it means is when you detect that a button has been pressed, you don't go looking to see whether the button is pressed for a particular period in time. So you're not constantly reading the fact that the button is still being pressed. So we might just ask in chat, can you add some button debounce logic? And let's see what it does. So it's going in the right direction. It's basically saying, well, okay, I guess we need to have a time. Oh, I should let it explain it. So last button press time, to keep track of the last time a button was pressed. Yes. So I'm unsure as to whether or not that's good enough. Because there's only one variable for all of the buttons. So that really means that you can't press two buttons at the same time, if that occurs. So we might say the logic needs to allow multiple buttons to be pressed. We'll see if it comes up with anything. Yes, okay, so it's creating an array that it can keep track of all of the buttons. That's what it looks like. Which, just on the face of it, sounds like a really good way of doing it. Excellent. Well, I'm going to integrate that into the code and we'll see what happens. Just copy this over the loop. And it's redefined missile X. That's fine. We'll get rid of that. So now we've got this new array that's keeping track of the time between the buttons pressed. And it's given us a 100 millisecond time. So a big better if that was a variable, then we can change it. So perhaps we'll do that. I'll just quickly define a variable. It should probably be a const, but so I'll call it dbounce milliseconds, and I'm actually going to make it a full second because I want to see the effect that it has. So I will just, what am I doing? I just want that. I'll just copy that and replace it with the variable. That way we can just change the variable and the dbounce logic will change on every button. Okay, we really shouldn't have this delay in here, the 100 millisecond delay. Although we are redrawing the spaceship every time we're doing this, which we need to change. We should only draw the spaceship when it moves. But let's just see if that runs. Okay, so erase pixel. Yeah, so it's gone back to that logic that it had given us earlier on that we had to change. So erase pixel is actually our equivalent of set pixel false. And drawing a pixel is set pixel true. All right, so you can see I pressed the button. I'll do that again. So I'm going to press the button down, moves down, and then I keep pressing the button, but it only takes one input every second. Maybe it would be more obvious if I changed it to 10 seconds. So that's 10,000 milliseconds. Just restart that. So what should happen is I'll press the button and it will react. No, it won't. So it won't react until 10 seconds is up. We'll just keep, and there it goes, and then it won't react again. The only problem is that it didn't react. I'm pretty sure it didn't react instantly the first time, or did it? So if I press down, no. So it's counting 10 seconds from the moment that the program starts, which isn't ideal. So we'll just need to change that logic. I think what I will do is I will bite the bullet and I'll redefine this dbounce milliseconds as a constant. And you're supposed to have them as capitals. It's an int. So I'll do that. If you're going to use a value and it doesn't change when the program is being run, it should be in the C language, it should be defined as a const. And what I'll do is I will then, in this initialization section, where it initializes the arrays, I'll set it actually to the value of the dbounce, which means it will already have met the criteria by which you can press the button again. See if that works. Oh no, of course, I need to change all of these to use the new constant. No problem. Should be it. Okay, so now if I press the button, it immediately allows you to move. But then after that, it requires 10 seconds before it will let you move again. The 10-second thing was just so that you could see it working. So we can go and change this to something more practical. Let's call it 500 milliseconds, half a second. Oh, maybe that's too much. Maybe 200 milliseconds. I'm not 100% sure. It's the sort of thing that we need to try. to get right. But that's implemented now, so that's another thing done. The other thing that we wanted to do was to set the speed that the missile travels. And we can just use exactly the same logic. So we might as well just do that. So we can create another const. Missile underscore speed equals, I don't know, 500 milliseconds. Does that sound reasonable? I need to concentrate on what I'm doing. Last missile moved time equals missile speed. Oh, we're going to set that to 0. So we're going to use that in the same way that we've used the last button press time. So we want to limit the speed that the missile goes. So I've done that. Basically what I did was I copied the same logic. I said, look, if the milliseconds, the current milliseconds, because the CPU, like a microprocessor, doesn't have a clock like a PC. So it does keep track of how many milliseconds it's been running since it was powered on. So you can use that. So we're saying, look, if the milliseconds minus the last time the missile moved is greater than the missile speed, then you're okay to move. And then we set the last missile move time to the current milliseconds that have passed, and that will prevent it from moving any faster than the missile speed variable. So if I run that and we fire the missile, it goes at a particular speed, and we can go and change the constant. So that's set at 50 at the moment. If we set it to 500, it will move much slower. So we'll stop that. Yep. So we'll change it back to 50. Pew! Okay, that's another thing done. Before we go too much further, I think we should simplify the code that's in this loop to keep things neat and tidy. So for the button logic, I think we'll just create process buttons function, and I'll copy that out. Copy that in there. And we've got this missile move logic. So don't need that. We'll just give that a bit of a test. Perfect. Okay, we're really getting somewhere now, but we're coming probably to the more difficult part of the project, and that is, well, we need to produce some enemies that come at our spaceship, and we need to implement the logic of the missile colliding with an enemy, or an enemy colliding with our spaceship. And collision detection is quite an art form, and there's plenty of different ways of doing it. They all have different advantages. Some are very fast to calculate, others are more accurate. I'm very interested to see what chat will produce in respect to this. think it's time to implement the alien or the enemy. There are a few ways we can do this, but when you're writing code, it's really about reusing code that you've already written or the patterns of code that you've already written. So we've already defined a spaceship and having a way of moving that spaceship around. So let's do the same, but with an enemy. We won't go into making multiple enemies because that would take too long, and I want to keep this video as short as possible. And that's something that you can implement yourself once it's all working. So let's go up, and we've got this array here that defines our spaceship. So we can copy that. Call it an enemy. And I think I might try and implement my favorite enemy, which is Space Invader type-esque enemy. Quite difficult to create anything in great detail at this level, but he'll sort of be, he needs an eye. I don't know how that's going to look. We'll have to actually get it on the screen before we can decide whether we want to keep that, but that doesn't matter. It's just a matter of turning on the pixels here, whether they're 0 or 1. So let's copy this code here. We need an enemy X and Y position, absolutely. Sounds good. What else have we got here? So we've got a raise spaceship and a draw spaceship, and we probably need the same thing for the enemy. If we're optimizing this, we would probably change this to a raise sprite and draw sprite and then pass it the array of the enemy, but we're going for simplicity at this stage. So let me do that. I'll just copy these functions. Okay, that line, since we have the set pixel routine. Now I could get chat to do this for me, but I think it's simple enough to do it in code. Yeah, that looks pretty good. Let's just give this a quick test by manually putting an enemy on the screen in a certain position. And we will need to give a starting position for the enemy. Let's call it, since this is 0 and this is 31 and it's 4 pixels, let's call it 25. So we'll do it at x25 and at y4. Right, let's see what this looks like. And there's our little enemy there. Yeah, maybe if we put a dot there, he might look a little bit more like a Space Invader. Let's try that. Yeah, that's what I'm after. Okay. And of course we can just change his starting position. Let's call it 0 to make him move up in the Y direction. And everything else still works. Pew! All right, now we're getting somewhere. Looking at the loop, you can see that every time we're looping around, we're erasing the spaceship and erasing the enemy and then redrawing them. The move missile, on the other hand, is checking to see whether the missile is active and only erasing it and moving it and redrawing it if it is. I think that we should probably do the same thing so that it only draws the spaceship when it moves the spaceship, or it puts it into a different position, and the same with the enemy. So I'm just going to optimize that. The way I'm going to do that is I can see in the process buttons that we're moving the missile position. And I think it's in there that we need to say draw it. So first of all, erase it from the position that it is currently in and redraw it in the new position. I'll just quickly do that. So I've implemented that code. I'll just give you a demonstration. When the alien is drawn on the screen, it will move from the right-hand side to the left-hand side until it disappears. And both it and the spaceship will only get redrawn when they're moved. So to do that, I essentially copied the code that was in the move missile and I applied it to a move enemy routine. And also in the process buttons, I said, erase the spaceship before you update the position of the spaceship. So erase it first, then you can change its X and its Y position, and then you can redraw it. So that stops it being redrawn every single time it goes through this loop. And that simplifies the loop now to process buttons, which will move the spaceship around as well, based on what buttons are being pressed. Move the missile. So if the missile appears on the screen, it will move it constantly in a direction from left to right. And move enemy. If the enemy is drawn on the screen, it will move it from its position at the right-hand side to the left-hand side until it disappears. That's pretty much everything we need. We simply need to spawn the enemy randomly, and we also need to implement the collision detection. So if any of these objects collide, then we need to take some form of action. If a missile collides with an alien, obviously the alien needs to die. And if an alien collides with the spaceship, then it's game over. Time to introduce some spawning logic. We've already got in our move enemy function the code that basically says the enemy is considered to be active when it has an X that is greater than -4. When it's -4, it's because it's 4 pixels wide. If it's -4, it's moved completely off the screen if it's traveling from the right-hand side to the left-hand side. Why don't we introduce a variable to make it easier for us? A Boolean called enemy spawned to indicate whether or not an enemy has actually been spawned and is currently active. And when it has reached the end and turned inactive, we will say that the enemy spawned equals false. And let's create another function which spawns the enemy. And that way we can have some logic that says if enemy spawned equals false, then let's spawn the enemy. To spawn the enemy, we just need to give it a some coordinates. Well, an X position that is greater than 0. So we'll spawn it at X24. And give it a Y that is a random number. So random between 1 and 4. And then obviously we need to set enemy spawned equals true. So this will just keep spawning an enemy after enemy immediately after the enemy has disappeared. Obviously we need to add some randomization in there about when it spawns, but we're just going for simplicity at the moment. So let's see what happens. Yep, and so it's spawning the enemy at different Y positions. And we want to, that should be 20, so we've got 32 pixels, that should be at 28 rather than, okay, so we've got that. The enemy is traveling much faster than the spaceship can move and the bullet, so yeah, that's great. So now we need to implement the collision detection. All right, before we go too much further, let's talk about collision detection in video games and how it relates to this module that we're using in our video game. In our game, we've defined a spaceship sprite with a 4x4 pixel array, and we've got an enemy with a 4x4 pixel array, and we have a missile which is a single pixel. So let's imagine that this is our spaceship that we have defined. So we haven't used all of the pixels that we have available to us. And the same with our enemy. We've chosen a different shape and we haven't used all of the pixels that we have available, the 4x4 pixels. How do you figure out, oh, and there's a single pixel for the missile. So how do you figure out whether or not the spaceship has collided with the alien or the missile has collided with the alien? There's a whole bunch of different techniques that you can use. And one of the most common is using a bounding box. And this is where you would define a box or a rectangle around the sprite that you're using, and the enemy that you want to compare it against, for instance, and then you would do a mathematical equation to compare the two rectangles to see whether they overlap. So to do that, you would have to define, a rectangle that would basically go around it like that. And in this case, a rectangle that would go around it like that. This is not something that you see. It's not visual. And then you can do a mathematical equation that compares whether or not this rectangle and that rectangle overlap. And you can say, well, they do. In that case, they've collided. Now, because we have such a small display and such large pixels, it's going to be fairly obvious that there's an area in this bounding box where the pixels aren't lit. And if we use this technique, that would mean that any time that this rectangle collided with this one, it would say that it'd be a false trigger if, for instance, it collided here where there's no pixel being set. So how does it get around that? Well, the thing is, it doesn't. And this is very common in older arcade games because, you know, you would shoot something and you would swear that you actually shot it when you came very close to the edge, but it didn't register. And it's probably because of this bounding box problem. Now, the other thing you can do is you can say, well, let's just make a small bounding box here, in which case, you know, there's a couple of pixels. We do the same here. There's a couple of pixels which are outside the bounding box, which mean you get the opposite thing, is where they definitely would collide, but it wouldn't pick it up, because even though the pixel physically overlaps on the screen, it's not part of the bounding box. Now, the reason that they use these type of techniques is because they're very efficient to calculate and they're quick to calculate. So if you have lower spec machines, that's really important. The missile isn't such a problem because it's only 1 pixel. The other thing that they often do is they will look at the shape. The programmer will look at the shape of a particular thing. So let's say, you know, you have a shape like this, and you'd say, well, how about we have a calculation where the bounding box is a triangle and we're comparing it against a bounding box which is a rectangle. Would that work? And yes, similar calculations can help you do that. And of course, you can do circles as the bounding box, and you can even combine circles and squares and triangles to get a more accurate representation. Anyway, so that's probably the technique that we're going to use. I don't know yet because I haven't spoken to almighty ChatGPT. We'll see what it comes up with, but this is pretty much a classic way of doing it, and I imagine that will be require the least amount of programming resources. Let's go and find out. Let's see if Chat can help me with collision detection. I'm programming a video game on an Arduino Nano. I am defining my sprites like this. And I'll just give it the arrays that I'm using. Can you help me with detecting collisions? That looks like what we need. It's given a pretty sophisticated roundup of the different types of strategies using for collision detection. So I think we'll try this. I'll just copy the code that we got from Chat, and I'll just quickly run it without using it just to make sure it compiles. I don't know of a better way to check if it compiles with this simulator. So basically it's checking for a collision if we're giving it the coordinates and the width and the height of the bounding boxes of the sprites that we're interested in. So I'll implement that and we'll give it a test. That's done. So I just added these lines here. So check collision, spaceship X, spaceship Y, 4, 4. So that's the dimensions, the width and the height against enemy. And it will then print out something to the serial debugger, and then it will actually just stop. So the program will freeze. This while one just means it will loop continuously here. And also the same here, check collision between the enemy and the missile. So let's give it a go. I also slowed down the enemy so it was more obvious. So if I press play and the enemy collides with the spaceship, it pauses. So if I restart it, if I move down and shoot and the missile hits the enemy, it's paused again. So it is actually, and it's saying that the missile and the enemy have collided. So that's working. We're getting pretty close to the end of the game now. So I think what's missing is we need a game over screen. So we might do that next. So I've written quite an extensive question for chat. I'm saying, look, I'm programming an Arduino game, have a display that's 32 pixels wide and 8 pixels high. I have a function to draw the pixels called setPixel. Can you help me write a screen that says over using that function? And can you define each letter in a 5x5 Boolean array? And the letters need to be drawn left to right. This is after asking it numerous times to do something sensible for me and failing. Okay, just trying that out. Oh, nearly. I don't know why it's put an X in there instead of a V, but that's okay. The reason why I wanted to put them into these Boolean arrays is because it makes it easier for me to modify them by just setting the different bits. That's it for this video. So I'm probably going to spend a little bit of time cleaning up this code just a little bit before leaving it as it is. You can come and download the code as it is right now by going to the Wokweir website. I will leave a link in the description. I'm going to do a part 3. It's going to be quite a short video. I'm basically going to play around with some of the code, see if I can improve it a little bit to make it more playable, perhaps resize the enemy sprites to make it more like a game. But the important thing is I'm going to build this video game. So I'm physically going to get some buttons and an Arduino Nano and that display, and I'm going to build this video game, and we're going to download this code from the Wokweir website and see if it runs in the real world. See you then. Ciao.